This video will demonstrate a Path Designer feature for automated desktop design of a point-to-multipoint network, achieving lowest BTS count and maximum CPE connectivity. This will be done in two parts. Part one will be a fast walkthrough without detailed explanation. This will give the user an appreciation of what's possible very quickly without being bogged down in detail. The second part will talk about the preferences that are set up and the details in terms of the way that the process can be made to unfold. So there are different ways of doing things, different options, and these will be discussed in part two. The process starts in the Path Designer main form. This tool has been loaded with a project consisting of 55 sites and no paths. They are the sites that will become ultimately BTSs and CPEs in this network. I'll show you the site manager quickly so you can see the list of 55 sites here. And you can see it says 55 at the top. Behind these rows, this listed row, there's a lot of detailed editors for each site. There's a path manager, which is also a listing of paths, in this case with two views, but they're empty. There's no paths in the network. Now I'll show you, I've plotted this in path loss, and I'll show you what the map looks like. So for this example, this is the collection of 55 sites that are clustered geographically, and this we're looking at in a path loss GR5 map. To start the process, we go into the network menu of Path Designer to the point-to-multipoint design selection. And this brings up a editor form, or it's actually a process form for designing the network. And you can see there's steps across the left here. Now we start by setting up design preferences. I'll bring up the editor to show you. I'm not going to go through these choices presently, but I will point out that we have a 3-mile maximum path length, which is pretty much what we get with close-to-close sites in that map I just showed you. We then create links by clicking this button. The links take into account obstructions, clutter, and terrain obstructions, and they also have criteria for whether or not they should be accepted based upon minimum RSL, minimum fade margin, or what I've used in this example is clearance. So it's come up with an answer of 463 possible links between these 55 sites. To now select BTS sites and assign sectors, I choose the sector template that I want to use, and I can use more than one. This is a template in Path Designer that's essentially a set of equipment that defines a sector. In this case, I've selected a 90-degree sector. So I simply say choose BTS site and assign sector, and in less than a second it has found which sites are the best BTS sites by decreasing order of connectivity, and if you use them all you'll get a good network. So BTS site 35 connects to 15 CPEs. So that essentially is my answer, and I can see this in an Excel report. If I click on the Excel report button, so here's the Excel report, and you can see BTS site listed down the left, sectors, sector azimuths, antennas, CPEs that it connects to. Each row in this report is a connection to a CPE. So in this example, this is sector number 1 of site 35, connects to 5 CPEs, and these are the CPEs. And as you go down the list, you can see them all. And it includes, as I said, the sector antenna, and the beam widths, and the azimuths. Okay, so going back to our process, if we're using path loss, we'll continue the process. If as a user you're not using path loss, and you're not obliged to, there's been no interaction with path loss at this point. But if you don't want to use path loss, or you've got other systems to work with, you simply exit this form, and you've got a design. It's stored in Path Designer, and you can do a lot of things with create a lot of reports, go through the editors, and so on. You can drive Google Earth and ArcMap and a number of other mapping features, for example. But I'm going to continue in this demonstration by showing you how to create the path loss link files and map GR5 file. So in the next step here, which is the next 3 steps, or the 4 steps, have to do with path loss. So I plot the GR5, and I'm going to save it as S6, which is step 6 in my process. And you'll see visually what the network looks like that it found for all those sites. And at this point, we have defined the BTS as the CPEs, the sectors, which are the arrows in path loss. And there are editors behind it, I'll show you later. But right now I want to create the link files so that I'm going to work with in my network. So I go to the path loss, whoops, excuse me, I'll try again, to the path loss design links menu. And again, there's more settings under link design rules we'll look at later in part 2 of our presentation here. But right now we just click design links and finalize, which creates the files. We select where the files are going to be saved in my path loss files folder here, for example, and we exit and we close this. So now we have link files, and I can show you those in my folder here, in my path loss files folder. So these are all the link files it created rather. I'll just open one randomly, take a look at it so you can see the file. We'll go back to this later on. So the next step in my process working with path loss is I want to write all the detailed information from Path Designer that makes up these links, which includes the antenna center lines, the sector azimuths go into the link files, equipment as well, and we also solve for lowest CPE antenna heights, which was one of the options in the preferences we'll talk about later. So I simply write, and in a second it'll be done. And when it's done, then we create our final map, GR5 path loss map, and that's going to be the end of the process, and I'll just show you a few results. Okay, so we've written all the equipment, antenna center lines, and found the lowest and center lines for the customer premises. Equipment, now we plot the final GR5, and let's call that S9, which is step 9 in our process. And the map will look the same as before, except now there's a lot more information written into the files. I'll just click on one of them to show you. Antenna heights. So this is a link file. On the left is the BTS with the antenna height that was set. On the right is the customer premise site, and you can see that it's quite a bit lower. The tool, as I said, found the lowest possible antenna height for this customer premise site while achieving the clearance criteria for Fresnel and K-factor, and it includes, of course, the clutter. And you can see it's just skimming because it's set it to the lowest possible point. If I look at transmission analysis, the radio is the models that came out of the templates in Path Designer with their specifications, and they're linked back to the files, the path loss files. If I look at antennas, the BTS on the left is a 90-degree antenna sector model, and the customer premise antenna here is also came out of Path Designer as one of the setups and the preferences. The sector azimuth, this 90-degree sector, is pointing at antenna azimuth of 0. 10 to the minus 3 is shown, but it's really 0. But the azimuth from the BTS to the customer premise site is actually 39.36 here. So we're not in the center of the beam width of this 90-degree sector, which happens for most customer premise sites, but that's caused the system to incur a slight loss. So the orientation loss is 1 dB here. So that's a good thing that we've included this so we can make sure that our availability on our links is good. And so this is the resulting calculation. So now we have, as I said, the map and the link files. I'll just quickly look at the editor for the BTS here. I'll pick one of them. If you bring up the base mobile specifications, this is the sector area. We're looking at sector 1 of 4. There's 4 settable. And this is a BTS antenna of 90 degrees with a 0-degree azimuth. Sector 2 is also 90 degrees, but now it's at 90 degrees. These azimuths are part of the preferences that we'll talk about also. Okay, so that's essentially the end of the process. We have all our files created, everything's designed, everything's chosen, and it's done in a way to minimize the number of BTSs while connecting to the maximum number of customer premise sites. So now we'll talk about the details in the preferences. There's a lot of detail here, and it may not interest people who are not actually doing the design, but it gives you an appreciation of the power of what our choices are. So I'll go into that now. So in our design process form, at the top we have a preference setting. There's also a preference setting several of them actually in path loss, which I'll show you after. So if I go into this one first. Now, most importantly is we use templates for BTSs and sectors in this process. Path Designer includes within it definitions for what BTSs can be and what sectors can be. So I'll go into the BTS editor from this button here to show you this. And so you can see here at the top there's a template listing. I have 2 BTS templates and 3 sector templates here. And very quickly, what a BTS template defines is a lot of settings associated with point-to-multipoint systems like multiple access technology, duplex technology, and so on. And it also defines what equipment goes into the remote sites, and that gets applied through our process to those sites. So there's radios and antennas and lines, and these choices are driven from our master equipment database, which is loaded into Path Designer. There is a master database connected through the web, but the tool accesses it and we load what we want. So these are those selections. Now the sectors, I'll just choose say a 90-degree sector here. The lower portion of this form defines the sectors, in this case the template. So it has the radios, the antennas, the lines, some channel information, polarization, and so on. Now for our application to our automatically designed network, we care obviously about equipment, the radios and the antennas most of all, but also the azimuths and the down tilts. So the antenna is the most interesting. We're talking about a 90-degree sector here. So I'll show you the specification file behind this definition. By clicking on this button, I'll go into our antenna manager, and the antenna manager just gives you a quick high-level view of specifications. But if you want to look deeply into the specification, we use path loss specification files. In this case, it's an ASD file for an antenna. If I open it, it'll open that editor in path loss, and just shrinking the form so it fits a little better. And this is their editor, and there's a curves menu item which brings up the antenna pattern, or patterns actually, and it starts out, this is the azimuth pattern, the horizontal pattern. For horizontal there's a vertical, and there's also an elevation pattern, and this gives you the losses on the vertical elevation. So these are used in path loss, and they're assigned into the equipment. When we assign them to a path and to a path loss link file specifically, they get attached to that link file and they define the specification of those links. So that's the templates in our preferences. So up here I choose the BTS template. I'm using template 3 in my example. And also in the process form, if you notice in the back here, there's these 3 templates for the 3 antennas, which we choose when we create the BTSs and sectors. So that's driven by that template selection. Now also mention that there's another sector template selection here. This is used in defining the gain of the system. So when we're creating links in the first step of the process, it's important what the antenna gain is for the sector. So this is kind of worst case. If you had different size sectors in your network, you would want to use the widest beam one here because it would have the lowest gain. Okay, so just going through these selections here now. Antenna center lines on sectors and customer premise sites can be set as absolute values, or we can use manager values. Every site, as I showed you in the list of sites at the beginning, behind that there's an editor for each site, and they include antenna center lines. These do not necessarily force the values into the paths, but they're defaults. We can also set to, as I showed you, to optimize the height at the customer premise site. That's this checkbox. So it'll find the best antenna center line to achieve clearance within a range of heights. The clearance specification is actually set at the bottom here. In this case, I'm using 4/3 K-factor and 100% Fresnel with no additional margin. And we're also excluding clearance problems within the last mile of the paths. This is an option. You can just put in 0 or turn it off. On the left here, which is a very important point, is we can choose to only use BTS sites which have been predefined as BTSs in the site editor. If you remember, I showed you all the sites were RF sites, essentially unassigned as a type. If we had edited one of them to be a BTS, or 2 or 3 of them, then by selecting this option, then no other sites will become BTSs. Everything else will be treated as a customer premise site. In my example, I use any site can be a BTS or a CPE. The only exception, which is important, is if we have sites predefined in the editors of the site manager as a BTS, they stay as BTSs because they may exist. So that's important. Now I'll jump to another place in the form here. If we have existing BTS sites, one of the options in this process is to add CPEs to the sectors on that existing or those existing BTSs, and another option is to even add new sectors to existing BTSs if needed. And the choices for how many of each sectors and BTSs you can add are part of the rules we'll talk about in a minute. We can choose to use site elevations from the terrain data files, which are used for profile analysis, for example, or we can use the site elevations that are in the site manager editor. Every site has an edit point for site elevations, so if they're surveyed and accurate values, we would want to use those. I'll go back to the middle portion here in a second, but I'm going to jump to the end. Sector setting criteria, in other words, selection of settings of sectors. We have a maximum number of megabits that a sector can support as an option, and we can set the requirement on a site to a specific value. So if I'm using 200 megabits maximum on a sector with 10 megabits site demand, then we'd only get 20 sites connected to that any individual sector, which would drive possibly the need for more sectors to be added. If we turn off the site value checkbox here, it'll take the megabits value that's in the detail editors for the sites. We can set the maximum number of CPEs per sector. That's part of the process when it's assigning them. It looks at that. Maximum number of sectors on a BTS and maximum number of CPEs per BTS. So it's possible to fill up a BTS completely and have to choose a second BTS to cover sites that might otherwise be connected. So these are important rules. This list of azimuths that's here, you can edit them and add and subtract to them. They define, if there's some numbers in here, they define what the azimuths of the sectors have to be. So this list defines the requirements, and that can be very helpful for avoiding interference in a congested network with multiple BTSs. You want all your sectors aligned to avoid interference. If this list is empty and you just go through and delete them all, then the tool will set azimuths to the best choice to cover the geographical coverage of the customer premise equipment, or sites rather. So that covers most of the issues here, most of the discussion here. One important point I didn't talk about actually, I didn't talk about the criteria for creating links. So I use clearance criteria, which is this factor, but we could have set minimum RSL as a requirement or minimum fade margin as a requirement. If we're creating links in Path Designer, as we are in our example here, and as we've selected, then we have to point it at the terrain files and the clutter files. So these are the folders. And currently Path Designer supports SRTM terrain files and the USGS land cover data files. We can exclude coverage within, or rather clutter within a given distance of the path ends. We can stop if we don't find the files, and we can choose the diffraction method we want, either ITU or Anderson 2D. PathLoss offers you a lot more choices, so that's one of the advantages of using the PathLoss 5 method, which would mean that the links would all be created in PathLoss and they just loaded into Path Designer. It's a very simple difference, but it has a disadvantage in that PathLoss does not handle very large numbers. It clogs up. Path Designer can run with far more links. Also, the step size of the terrain affects the speed and accuracy of the analysis. So normally I use 328 feet or zero point 0.1 kilometers step size, so that would define how many data points there are in the profile. We can also go to 0.01 in this tool in Path Designer. It slows it down by a factor of 10, of course. And if the system has too many links or too many steps in the links, in other words, takes a lot of processing time, it will give you an alert and warn you and tell you you can go and change it before proceeding. Similarly, there's a progress selection down at the bottom here. Normally, you'd want to know, if it's creating links, how many, how many is created and how long it's taken, to give you a handle on how long before it finishes in a large network. If you show that progress, it takes a lot longer because it has to update that progress indicator. So it will tell you if the time is long, it'll warn you. You could turn that off. So that's these preferences. Now I'm going to go into path loss again and show you the selections there when populating PL5s. So let me just do this very quickly. Now I plot my GR5 as before. This was step 6. Excuse me, step 6. And if you remember, we went into the design links function. And in here, there's link design rules. And there's a lot of settings here, and I'll just show you a few of them. Profile generation is using terrain and clutter, the optionally clutter. And we can use site elevations at the endpoints that come from the site data in Path Designer, or we can use the terrain points. In our case, the actual what comes from Path Designer is the same because it read the values from there. Antenna heights, we would normally use the assigned antenna heights out of Path Designer. Coupling unit is additional losses if you want to include some losses. Equipment specifications, very important if you're looking at fade margins and so on. And there is a possibility to load an equipment template, essentially just a link file. Other choices are reliability parameters, C factor, that kind of thing, range zones, if you're trying to reject links based upon something like that. Now, in our case, these links have been set up through Path Designer, so we're not interested in rejecting anything, and we have our own equipment specifications. But this is very useful if you're creating links in Path Loss. Similarly, if you're creating links in Path Loss, you might want to reject them based upon, say, fade margin. If it's less than, say, 20 dB, you don't want it, that kind of thing. So you would enter whatever your criterias are in here and reject the links. So that's all of these parameters that you can use when you're doing your design. So that concludes my discussion. There is more detail, but I think I've given you a very strong appreciation of what is included in these designs. I hope this was interesting. Thank you.